All right, welcome to a new unit. We've got a bell work here, which is very similar to the stuff that we saw in the last unit. A little distribution, some combining like terms to simplify the expression. Okay, so we got this expression right here. It is an expression because it does not have an equal sign, but that's going to change a little bit today. And so I got to distribute. Now be careful because some students look at this as though it's a 4 that's being distributed, but actually the term itself would be a negative 4 because of the minus sign to its left. So that would be negative 4 groups of 3 x's. So that's negative 4 times 3, which is negative 12. That's how many x's there are. And then I'd have to distribute that negative 4 to the 5 as well. Remember, distribution is multiplication. So it's negative 4 times 5, which is negative 20. Okay, so now you got 2x minus 12x minus 20 plus 15. So from here, all we need to do is look to combine any like terms we have. And I got these 2 x's right here. The 2 x's minus the 12 x's. How many x's is that? 2 minus 12? It's negative 10. And then the constants, negative 20 plus 15. So negative 20 plus 15 there, that would give us negative 5 constants, okay? So again, I think we talked about this last time. Some students are still not sure if they need to add or subtract. Like between the x's, remember it's showing a minus sign right there, so that's how we know to subtract. Or between the constants, it's showing a plus sign right there. That's how we knew to add with the constants. Okay, so you could have written it like this. Of course, you could have rearranged it with the negative 5 in front and then the negative 10x second. Either one of these would work, but I'll go ahead and box this one in. All right, there's our objective for the day. I can solve equations with one principle of equality. And yeah, this is kind of a new term for us, principle of equality, and also equations now. But it has a lot to do with what we've been seeing already with expressions. Now they're just equations. We'll talk more about that here in a second. Take 30 seconds to copy this down though, please. Okay, so equations versus expressions, okay? So equations will always have an equal sign. Really what an equation is it's a comparison between two expressions. Now what we learned in the last unit is sometimes an expression is just a number. So you could say, well, I'm going to compare 5 with, I don't know, 5, something like this, okay? Now this comparison is a true comparison, okay? Really what we end up with equal signs like this is kind of a question mark. Is it true or not? Okay, and right now it's true. Now, could we change this to be false? Yeah, we could easily do that by changing this 5 into, I don't know, 4. See, now this statement is false. But I could make it true if I just adjusted this just a little bit by saying 4 plus 1. Okay, now this is, again, a true statement, all right? But that's what an equation is. Like this is an expression, 4 plus 1, and then 5 is its own expression as well. It's 5, okay? But when we look at an equal sign, it has to make the comparison true. Another point on this one here is that we talked about this early on in the class, but sometimes math is just what you want it to be. So see how this is still a true statement? And what I could even do right here is I could say, look, I'll just add 0 to this. This is still a true statement. Did I have to put that there? No, I didn't. But if for some reason it helps me, which later on you will see that it will, not in this class, but somewhere else, then you can do that if you need to, okay? So as long as you're operating within the rules of mathematics, there's actually an unlimited amount of possibilities that you can do. And if you understand that, like instead of 5, you wanted to put this as 4 plus 1, then you can do pretty much any type of math. I'm talking all the way up into calculus and beyond that, okay? So this then goes into what a solution is, because you're going to see problems say solve for x or just solve, and that's really saying what is the solution. I like to think of it more like this: what value of x makes the equation a true statement, because that's what we're going to see is x type values, okay? So a solution to an equation. So for these types of equations, you're going to see variables in the equation. But now we need to make sure that whatever value that we replace the variable with makes the equation true, okay? So on that last example, like this one, okay? So this right now is true, just like we saw on that last slide, but what I'm going to do here is I'm going to take that 1 and I'm going to replace it with x. Okay. So there's a nice x right there. But the question then becomes, well, what value of x would make this a true statement? That's what it's asking here. Okay, so that, again, that's kind of what this question mark is asking here. What value of x would make this true? Well, I know that the only value of x that would make this equation true is if I replaced x with 1, okay? And that's what this statement is making. If you replace x with 1, then the original equation is a true statement, okay? That's what this is saying right here. If I replace this x1, if I replace that x with 1, I get a true statement, okay? Now, of course, this one may not take a lot of thought to do this one, and for some of you it may take a lot of thought because this is new for us, and that's fine. My expectation right here, right now, since everything's very new, what we're going to be doing in this unit, I just want to get you guys prepared for this. Don't expect this to come very quickly because it's a very new concept. This is where a lot of you that maybe perhaps did very well in 6th grade, you may tend to struggle with this because it's kind of a new concept. But if you can think of it like this, you're looking for an x value that makes this true, you're in good shape. Now, if we looked at this as well, okay, let's say instead of x being 1, and I wanted to replace x with, I don't know, 8, then you can see that I would then have a false statement, right? So is there another value that you could make this false with? Sure. If I made x 0, then it would be false as well. And so we see from this that the only value of x that would make this true is 1, okay? There's only one value here that would make this a true statement. And that's the one value that we need to find in all of these types of equations. So something like this. This is an equation, okay? And it's asking, again, what is the solution of this equation? What it's really asking is, what value of x would make this equation true? Okay, well, the only value of x that I could think of that would make this true is if I replaced x with 10. Boom, boom, right there. X equals 10. Now I get a true statement, okay? But again, I'm pointing this out. If you replaced x here with anything but 10, then you get a false statement. You could replace it with negative 10 even. It would look very similar, would look almost the same, but it would still be a false statement. That's the important part. There's lots of false values of x that would make this false, but only one that will make it true. So here's our next one, okay? So a little bit different, but again, this is the question. What value of x will make this equation true, right? Now, this may take some thought, and we do have processes for this, okay? But for now, just think about this. What value of x would make this a true statement? The only one that I can think of here is if you replaced x with 8. And by the way, this is how you would want to show your answer, x equals 8. I believe on the assignment, you're just entering the answers, the number on this, but in the future, you want to show that x equals 8 like this, so that people know from this equation, if you replace x with 8, you get a true statement. Would this be true? Well, replace the x with 8. See that? Well, 8 plus 2 does equal 10. And last time I checked, anyways, 10 does actually equal 10. That would be true. Okay? Now, again, this means if you replaced x with anything but 8, you get a false statement. You get like, I don't know, if you replaced x with 9, 11 equals 10. That's not true. That's not true anymore. Okay? And that's what an equal sign is. It's a comparison between really expressions. You could say values if you'd like. All right, how about this one? So that last problem, we saw some addition. Now we see some subtraction. But again, the main question here is what value of x will make this equation a true statement? We want it to be true. There we go. All right, now you could think about this. Especially while we don't really have any math methods to solve this right now. You just may have to think, well, what value, I would have to take 4 away from this, whatever this value is, to get 10 right there in order to make it 10, right? So I know that if I replace x here with 14, then I would see that 14 minus 4 would be 10, and 10 does equal 10. That would be a true statement, okay? So this tells me that x equals 14 is the solution to this equation. So just reiterate a few slides back is, this is the equation we're looking for, or the question we're looking for. What value of x makes this equation true? Solutions make equations true. That's why we call this a solution right here. X equals 14 is the solution to this equation. Now, think about this too. So x, I used x here, and on the last equation I used x, right? So on the last problem we said x plus 2 equals 10. Now, notice we're using the same letter, x. That doesn't mean it's going to always be the same value. Okay, this x here that I have in red is different than this x that I have in purple. It's the same letter, but it came from a different equation, so it's possible to have a different number represent this x right here, okay? So, like in this equation, if I replaced x with 14, then we know that would be a false statement. Or if I replace this x with this 8 right there, then it would be false, okay? So don't get this mixed up where it's like all x's are the same. No, it's a different x because it's a different equation. All right, so for this one, we got 5x equals 10. And so some students right now, because this is still pretty new, even though we saw a lot of this in the last unit, that's really 5 times x right there. So if you're not sure what operation that is, it's multiplication, okay? So the question is, again, that we really want to know is what value of x will make this equation true, right? Now it's 5 times x, so you could ask another question. 5 times what is 10? I don't know if that really helps, but it could, I suppose. Right here, I know that the only value of x that I could replace to make this true is if I made x 2, okay? Because 5 times 2, that would be 10, and 10 does actually equal 10. That'd be true, okay? So if you replace x with 2 right here, you get a true statement. So I see that x equals 2 is the solution. That's the solution to the equation. So if we look at that example, 10 times x equals 10. So again, this is asking what value of x would make this equation true. A true statement, if you want. And for this one, I know that the only value of x that I could think of that would make this true is if I made x equal 1. Because then you'd have 10 times 1, and 10 times 1 is 10. That 10 equals 10, that's true. And now I know that this x equals 1, that's the solution. So yeah, you got to be careful on these because it depends on what operation is being performed between this. Remember, this 10 right here is called a coefficient. That's what we learned last time, and x is considered the variable. So if it's a coefficient, then yeah, we get a 1. If it was like a plus right there, then I would say the only value of x that would make this true is x is 0. So yeah, the operation and the placement of the values makes a huge difference on what value of x would make it true. And so again, right now, this may take a lot of thought on your part, but with some experience, I would hope that this comes a little bit faster because 8th grade, if you can't do this in 8th grade, it's going to suck. And pretty much everything after that. If it doesn't show the operation between values, then you have to know that's multiplication. Multiplication is the only operation that does not always have to be shown. But addition, subtraction, and division always have to be shown in some way. Now that doesn't mean that we should see between numbers like this, 1 and 0. There's not like multiplication between there. That's just a 2-digit number. That's different. Yeah, so if the equation looks something like this, again, the question is the same. What value of x makes this true? Well, the only value that I could think of that would make this true is if you replace x with 1. All right, now this just happens to be the same equation, but it's just reversed where the x's are. Notice that the comparison between the two values is the same, 10x and 10. It's a comparison, 10 and 10x. It's just the location of the two terms is changed, or the two expressions as well. So here we got x divided by 2. So something divided by 2, something, that's what x right here divided by 2 is 10, right? But we want to know what value of x will make this true. What value of x will make this equation a true statement? There we go. All right, now again, this, you just may have to think for a little bit, figure out which value of x would make this true, but I know that if I replace x here with 20, that I get a true statement. In fact, let's show that. 20 divided by 2, boom, that's 10. 10 does equal 10, by the way, that's true. So then I know that x equals 20, boom, that is the actual solution to our original equation, x divided by 2 equals 10, okay? So what value of x will make this true? 20. And once again, if let's say you made x something other than 20, well, then you get a false statement because this expression would not then equal 10, which it needs to, compared with this 10, okay? Now we saw in the bell work, right? Sometimes you see some distribution, sometimes you see some combining like terms. We're not seeing anything like that right now, but expect to see that in the future within these equations. But first, we've got to learn our principles of equality. The first two that we have is addition and subtraction, okay? Now this is just really a mathematical way to do the problems that we just barely did. Not all of them, but the ones with addition and subtraction, okay? But I want to point your attention to this. We use addition and subtraction to make zeros. Okay, so we're going to take control of these values, these equations, these comparison of expressions, and we're going to force values to become zeros, force them, okay? And this is where we take control of the values in the equations instead of them taking control of us, as long as we understand these two principles of equality. Now, this is very abstract. I'm not actually even recommending that you read those. All they're telling us is whatever you do to one side of the equation, you must, we'll emphasize that, must do to the other side of the equation. Now, when we say equation here, we're talking about the equal sign, okay? So see how this is saying that if you have something that's equal to something else, and again, these may be expressions, A and B, like we saw before. Now let's look at that example that we saw before, right? 5 equals 4 plus 1, okay? Now that's a true statement right there, okay? But I can maintain it being true. I can keep it true if I were to, I don't know, add 3 to this side and then add 3 to this side. I could do this. I can just add 3 to both sides and then it remains true. Well, what if I didn't want to do that? What if I said, and I'll keep that at 5 there, just want some space. Let's say that I didn't want to add 3. Maybe instead you want to subtract 7. Well, as long as you do it to the other side, subtract 7, you still maintain equality. That's all this is saying, okay? Whatever you do to one side, you can do to the other side. But our objective here, when we use these addition and subtraction principles of equality, is to force values to become zeros, all right? Now, that may not make a lot of sense right now, but the nice thing for us is we're looking at what we call one-step equations, which means that we use one principle of equality to solve these, and then we're done, okay? Whether it's addition or subtraction today. Now, you can see there are these two operations. That should help you to know that next time we're going to be looking at the other two operations of multiplication or division. But that would be to create not zeros, but some other value. So, make zeros. That's what we want on this. So we saw this example before, and we know right here, if I made the x equal to 14, then I get a true statement, right? So that means if I replace x with 14, that's the solution. X equals 14, okay? Well, let's look at this with what we call the principle of equality. Now, this may not take a lot of thought for some of you. Some of you may take a lot of thought, and that's okay. But I'm going to use principle of equality to solve this. So here's how this works. Okay, so I put a line through that equal sign like this, and it's kind of, students call this an upside down T. I don't really have a good name for it. It's not technical. It's not academic. I just do it, okay? Why do I do it? Because, remember, the rule is whatever you do to one side of the equal sign, you must do to the other side. Okay? And that's what this line is here. So if I put something on this side of the line, I know I got to do it the other side over here, okay? Now remember, our objective right now, just like we saw on that last slide, is to make 0. Well, why would we want to make 0 here? It's because I don't, see how the solution shows just x equals 14? That means I don't want x minus 4. I don't want this minus 4 with the x. I just want the x all by itself. So if I can make this minus 4 a 0, which I can, I have that ability to do that, then I will arrive at the solution, okay? So this term right here, the 4, is actually a negative 4. How do you make a negative 4 a 0? All you're going to have to do here is add 4. See, because negative 4 plus 4 there, that is 0. Okay, but remember, whatever you do to one side of the equal sign, you must do to the other side as well. So where I'm showing a plus 4 here in orange, right here, I must show it on the other side of that line. So I got to show a plus 4 right there. Now, you know we can use calculators for this. So if you need to use a calculator for 10 plus 4, feel free to do that. Not something you should feel ashamed about, but I get 14 on that, right? Well, what the crap happened to this x? You can just drop it. Drop this x right there, okay? So you got, really what you have is x plus 0. So this is why we want to make zeros on this. Because whenever you get a plus 0 or even minus 0, you got to make it a phantom 0, okay? So it's really, again, that's really what we call a phantom 0. Why do we call it a phantom 0? That's there. Remember that plus 0 that I put right there? It's there. You just can't see it right now, which means it's a phantom value. So it's there. It's lurking in the shadows. It's always watching. Kind of makes these phantom values kind of creepy. But they're there. All right? And now what do we got? See this? It's x equals 14. That's what we already knew the solution was to make this true. Okay? So we're going to make phantom zeros out of addition and subtraction in order to make the x, or whatever variable it is, all by itself. So let's look at this next problem. And again, the real question here is what value of x will make this true? And again, do you necessarily need to use principles of equality to solve this? Maybe not right now. I think some of you may be able to do this without the help of principles of equality. But I'm going to keep using these because we're pretty much going to be using them for the rest of this unit and for a lot of the other units we're going to be going over in this class, okay? So remember, really what I would like to do here is just take this x and be able to drop it. I don't want anything added or subtracted to it, like this negative 14, this minus 14. I don't want that there. What I would like that to become is a phantom 0. See, I'm showing this plus 0. It was there the whole time. You just couldn't see it, right? So this negative 14, how do I make it a 0? Well, in order to make a value 0, really all you got to do is add its opposite. Or you could say subtract its opposite, however you want to look at that. But minus negative 14, if I add 14 to it, then I do get that plus, that phantom plus 0 right there. Now, I do want to keep it a phantom plus 0, though. And then what does this equal? So remember that line I drew through the equal sign? It's kind of like it brings down that equal sign right there. But the green plus 14 that I have on the right, I must show it also here on the left. And so again, if you need to use a calculator for this, then do it. But negative 18 plus 14 in my calculator, it shows x being negative 4 here, okay? Now, if we did this correct, if I replace x with negative 4, I should get a true statement. But let's check. Negative 18, it used to equal x minus 14, but now we're saying we know what the value of x is. Let's see what happens if I replace that x with negative 4. Okay, will this give me a true statement? And so I put a question mark over the equal sign to see if it is actually true. So on my calculator, negative 4 minus 14, and that tells me that I do actually get negative 18, which last time I checked does actually equal negative 18. That right there is true. Now that I know for sure it's true, then I know that my solution was true. X equals -4 is the actual solution to our original equation, so I'm going to box it in. And that's it. When you're checking these, make sure you put it in the same order that we have it, right? Like when I had the X here, I replaced it with -4, and then I typed it exactly like this into my calculator. I didn't move any of these values around. I just typed -4 minus 14. So yeah, these operations that I'm performing now are vertical, kind of like you used to stack and add or subtract stuff back in elementary school. So the last thing I'll say on here is when you go to check on this stuff, which you should always check, okay, is when you put this -4 minus 14 into the calculator, before you push enter, you should be expecting to see this -18. Now it's showing here, but it's the same -18, right? Because that's what will make it true. If you see something other than what would make the equation true, then you know you've made a mistake somewhere back here. So this process of checking that I do at the end, just to make sure that it's true or false, this is a way for you to know for sure that it's correct. So what this means that in the future, there's no reason to ask me, Mr. Sal, if this is the answer. You can check for yourself. Just put it into the original equation, see if it's true, because if it's not, then you know, hey, this is false. I know I had made a mistake. I got to go back and fix it. If you know this is false going into the assignment, and you put this into the assignment, then you can expect it to give you a 0 for that problem. But if you know it's true and you check to make sure it's true, you should expect that to give you full credit. So here we go. Yeah, this one's a fraction. We got 104/27 equals r plus 35/8. You guys try this one out. Take a minute, try it out, then we'll go over it, okay? But I'm going to go ahead and get started on this problem, okay? So, again, the idea here is to make 0, right? How do we know we're making 0? Because we got addition or subtraction on this with the r. Really what we want to do, though, is to just take the r and drop it, right? Like we've seen before. So this r, if I just drop it and then I get r equals something, that would be great, because then I would know that I've arrived at the solution, okay? It should be the variable equals something, which means I don't want this plus 35/8 right there, which means that to make that a 0, I'm going to have to subtract 35/8. Wait, so you're saying 35/8 minus 35/8 is 0? Yep, it is. And you can put that in the calculator if you need to. Now, when I put it right there, I just circled that, or some students think I circled it. That's a 0. See, because, I mean, I could put it right there at the plus 0. But then it becomes a phantom 0 anyways. But notice this minus 35/8, I did it to the right side of the equal sign. So I must do it to the other side of the equal sign, minus 35/8. Now, since you guys were doing that, I actually put that in my calculator. I put it exactly like this, 104/27 as a fraction minus 35/8. I put that in the calculator, and it told me that r would then be -113/216. Okay, now that's a pretty ugly fraction, but it should work. So on my calculator, I'm going to check this, because the original expression, or equation rather, 104/27 was supposed to equal the r value, but plus 35/8, right? But right now we think that the r value is -113/216. So all I'm going to do here is just check to see if this is true. So there's my question mark. -113/216 plus, there's the fraction button, 35/8, enter, and I got 124/7. That shows that this would then be a true statement. And I can go up here and box that in as my solution. So what about this one? Again, our objective here is to use principles of equality, and right now we're just looking to make zeros. Okay, really, it's to make phantom zeros. So in this problem, we're going to take this equation, and what I really want to do right now is take the n and just drop it, because then it would be n equals some value. I don't care if the value is a fraction, I don't care if it's a decimal, I don't care if it's a whole number or integer. I don't care. I just want to know what the n value would be. Now, be aware that the value that's being subtracted, 72/31, it by itself is considered negative 72/31. Okay, but we want to make it a 0. And to do that, I'm just going to add 72/31. Okay? It's just, remember, I just did it to the left side, so I got to do it to the right side as well. Plus 72/31. Okay? Well, that does make that a 0, which is just exactly what we wanted. But now I'm going to go to my calculator, and I'm going to push n over d, negative 61 all over 62. Make sure you get out of the fraction before you put in the next fraction, but that would be plus 72/31. Now you can push enter, and then the calculator says, again, it's not so pretty, but it'll work, 83/60, right? Now, if we've done this correct, we should get a true statement from the original equation, n minus 72/31. This should equal negative 61/60. Okay, so I'll put my question mark here. If I replace the n value with the value that we found, 83/60. Okay, so I type this into my calculator. 83/60 minus, there's the fraction button, 72/31. Enter, and yeah, my calculator gave me this exact fraction right here, negative 61/62. That means that that would have been a true statement if you replace the n value with 83/62. Now, this is a pretty precise answer with the fraction, but so are the other ones. It's just this one's kind of an ugly answer. But this means that if you deviate from this at all, if you use any other value for n, you're going to get a false statement. You need a true statement. Okay, now if by chance at the end of a problem you say, well, I'm going to test this out, see if this is true, and you end up with a false statement, that means that somewhere in here, either you failed to make a true phantom 0, you just thought it was a phantom 0, or you made some other kind of small mistake. Maybe you just entered it into the calculator incorrect. I do both of those all the time, so I really hope that you don't mind making those mistakes because, well, I don't know anyone that doesn't, but perhaps there is somewhere, I don't know. That's my recommendation, is just whenever you're doing these calculations, especially with the fractions, put these in the calculator. It will give you the simplified fraction which you will need. You'll need those simplified fractions. So I will emphasize this just one more time. There is a plus 0 right there. It's a phantom 0, you guys. You can't see it. And so, yeah, that's why we had to add that 72/31 to make that a phantom 0. I showed the 0 there, by the way, just I won't show it in the answer. All right, negative 30 equals p minus 19, okay? Now, what are we trying to do here? We're trying to make some kind of phantom 0, just like we have been on the other problems, right? Phantom 0. Okay, well, where are we trying to make a phantom 0? Okay, so you may have to look at this for a little bit, especially while we're getting some experience looking at this, thinking, yeah, where do we need the phantom 0? I want it right here. I want it in the end to be p plus, there's my phantom 0 right there, the plus 0. But right now showing p minus 19, dang it. I don't want that minus 19 there. Really, it's a negative 19, you guys. So how do I make that minus 19 a 0? Or negative 19, add 19. Okay, but if you do it to one side, you must do it to the other side right here, okay? Well, that should give me p equals, I'm going to make that a plus 0 right now, a phantom 0, okay? So I don't have to look at that garbage. Pretty much what we do is we treat phantom 0s like we do people that are 0s. We just ignore them, okay? I'm not saying you should, but that's what we do, right? So negative 30 plus 19, what do we get out of that? Negative 30 plus 19, I get negative 11. How do we get that? Just doing the calculator. Negative 30 plus 19, boom, got it. Let's just check to make sure. Okay, so the original equation, negative 30 equals p minus 19. But I'm going to replace the p with the value that we just found. We think right now that it's negative 11, and I'm not sure if it is. Let's check to see if it's true. There's my question mark over the equal sign. When I do this, negative 11 minus 19, I get negative 30. Well, negative 30 does actually equal negative 30. That would be true. So, yeah, I can go in and box in my answer right there. P equals negative 11 is the solution to our original equation. Now, like I said, it's not, right now you may not feel it necessary to use principles of equality, but I'm highly recommending that you do it so that you can get used to seeing it and performing these principles of equality. We're doing to these equations what we want to do to them. And again, the idea right here, right now, is to make some kind of phantom zero. Okay, so I want to make a phantom zero. I'm just going to set this up. Remember the upside down T thing just helps me to see if I'm doing it to one side, I got to do the other side. And right now, it says minus 2.1, garbage. I want that to be a phantom zero. I want it to be a phantom zero so I don't have to look at that garbage anymore. So I'm going to have to add 2.1. Okay. Right, so that'd be 0? Yes, it would. You can check in your calculator. Just if you do it to one side, make sure, please make sure that you do it to the other side. If you don't do this to the other side, it's not the principle of equality, and you will not have maintained equality. Pretty much what you've done is just change the equation, which means that it's just garbage. You do anything you want to if you're just going to do that, okay? Whatever you do to one side, you got to do the other side. And so the x, right, it drops just like we wanted it to. There is the plus 0 there, but it's a phantom plus 0 now. But the x now, this will tell us what x will equal. So in my calculator, negative 25.5 plus 2.1, enter. And my calculator says that if you replace x with negative 23.4, you should get a true statement. Let's just check to make sure the calculator is not lying to us. Not that it ever does. But x minus 2.1, right? Well, right now we're pretty sure x would equal then negative 23.4, right? So negative 23.4. And so I'm just going to type this into the calculator, check for truthfulness. Okay, so negative 23.4 minus 2.1, enter. And what does it give me? Negative 25.5. Hey, that looks like it's true to me. Since that is true, I can go back to my solution and I'll just box it in. That feels really good. So in this, so far with these principles of equality, you've seen it's possible to get whole numbers, negatives, fractions, decimals, doesn't matter. The principles of equality are true as long as you do whatever you do to one side. You just got to make sure you do it the other side. All right, on the assignment, you can expect to see some word problems like this one. Last week, Emily ran 36 miles less than Beth. Emily ran 15 miles. Write an equation to represent this situation. Okay, so Emily, right here, I'm going to use a couple different variables on this one. Okay, so we got Emily and Beth. And so usually I just use X and Y, but they gave us names here. So E will be Emily's miles, I guess. How far she ran. And then B, we'll make that Beth's miles. Okay. Well, right here, it says, hey, look, Beth ran 36 miles, or Emily ran 36 miles less than Beth. So this tells us then that if you took Emily's mileage, it would be the same thing as taking Beth's mileage, but see how there it's 36 miles less than that, so you'd have to take 36 miles off of that. All right? But it says up here that Emily ran 15 miles. So in this equation that I've written, now it has two variables, Emily's miles and Beth's miles, but then they said, hey, here's how many miles Emily ran right there. Oh, that's very nice of you to tell us, because now we could actually solve this equation or just write it. Emily's miles are 15 right there, okay? So that means if you take 36 miles off of how many miles Beth ran, you'd get 15 miles. How many miles did Beth run? This is the equation, by the way. This would be one of the boxes you'll have to fill in the assignment. But how many miles did Beth run? Well, let's rewrite this. 15 equals Beth's mileage minus 36. Hey, this is just a principle of equality one, where I'm going to solve for B in this case. So I'm going to take that negative 36, just add 36. Why are we doing that? To make a phantom zero. So add 36 to both sides. This will tell me how many miles Beth ran. So it looks like 51. That's a lot of miles. Maybe not all at the same time. I don't know. It didn't say. But we could say here that Beth ran 51 miles. Boom. Does this work? Well, 51 minus 36 is 15. So yeah, it checks out in the original equation too. But again, on Canvas, when you enter these into the assignment, you got to have both answers. Last Wednesday, Heather had $3. Over the weekend, she received some money for washing the dog. Now she has $61. Write an equation representing the situation, but the equation should be equal to $61. Okay, well, we're looking at how much money Heather had, right? So Heather, she started this $3. But then we added some kind of amount that she had for washing the dog, right? We don't know what that is. I'm going to use X. But then we'll say X is the amount of money she gets for washing the dog. Money for washing dog. Or the dog. I don't really care. Okay, so her original $3 plus the amount of money she got for washing the dog, yeah, that should equal the $61 that she now has after washing the dog. So this is showing that the equation equals 61. Okay, thank you very much. Now let's go to the equation and solve it. But again, this would be a box you're going to have to fill in. So 61 equals 3 plus x. We need to solve this, and it's nice that it's a positive x right there. That'll be important later. I'm going to solve this by making that 3 phantom 0. How do we do that? Subtract 3. But if you do it to one side, you got to do the other side. That's a 0 right there. 61 minus 3. Put that in the calculator, you get 58. That's x. Now, this is a word problem. Make sure you label your word problems, just like we did on that last word problem. It's $58. That's how much money she got for washing the dog. That seems kind of steep to me, but I could be wrong. For washing dog. All right, I'll put that dog. And so, yeah, we checked that, right? 3 plus 58 is 61. That's true. But yeah, if you arrange this differently as x plus 3, you'll still get a true statement. I just did it in order from where she started, right? $3, and then she got the 61 or $58. But you could say, well, you're just adding the two values. So amount that she collects from washing the dog and then amount from she had, yeah, it's going to give you the same answer. That does it. I can solve equations with one principle of equality. Again, the two principles of equality that we're looking for today was just addition or subtraction, right? Expect there to be multiplication or division in the future. But again, principles of equality is just saying whatever you do to one side, you must do to the other side of the equation. All right.